move, let's try something. Okay, let's look at the concerns we had. Firstly, you try with the architect's proposal, right? Now, if you move these columns with a common grid point and you position them here, now what you will see, so we are trying to do this preliminary structural framing. You would see that this column will puncture into the slab on the first floor. Okay, and if you allow this go to the roof the way it is, it means that it's going to puncture all through the slabs from the ground, from the first floor up onto the roof level. Okay, so the columns at the edge, this column, this would not be exposed because you have a wall there. Okay, so it's going to be hidden in this wall. This will be exposed, it will not be hidden. This will be hidden, but this column would not be hidden. This will puncture through the slab fully. This column would be hidden. This would be this would be, and so on. So based on this, what we decided to do was to flag up some of these columns so you could see the position in which the architect has originally presumed the columns would be. However, when you develop your structural framing arrangement, okay, your preliminary structural framing arrangement to carry the superstructure, you may find out that the column positions may either be uneconomical or may interface with the original aesthetic of the structure. In our own instance, we saw, look, red, the two red highlighted columns, you know, we had suggested back to the architect that this is going to be repositioned. Okay, so this is going to be repositioned. Now, some of these columns will not go to the roof. Most of them will terminate at the surface of the first floor. If you look at the yellow lines, that is the structural framing of the next floor. Okay, so this is structural framing of the first to third floor. So if you look at what happens here, you will see very clearly that these columns may not be able to work based on a structural arrangement. So it's the responsibility of structural engineer now to take up the responsibility or take up the onerous task of developing a structural framing arrangement. So let's look at what we have done. Okay, let's look at this very carefully. Let's look at what was done. Okay, so firstly, this is the, so what you see in yellow is the ground floor structural layouts. Okay, this is the ground floor, the ground floor architectural layouts. Now, to develop your structural layouts, what you would have to do is to, if you want to develop your first floor structural layout, you would use the ground floor and the first floor architectural layouts to develop your first floor structural layouts. Let's look at what we have done. Look carefully. Look, this is the architectural. Okay, let's take off some information that would interface with what we are doing. Okay, right. So if you look at this, this is the architectural ground floor layout. Look at where we have positioned our beams. Let's look at in the markers carefully. The columns that are marked as C2 and are colored white would terminate at the surface of the first floor. The columns that are marked as C1 and are colored green will start from the foundation level and go up straight to the roof. We would see why these decisions were taken shortly. The columns that are marked as C3 and are magenta in color okay, C3 and a magenta in color will start from the first floor and get to the roof level. How did we come about the decisions? Let's look very carefully. Now, this is the architectural. So what has been selected now is the architectural ground floor layout. So we have framed the beams as this, as what can be seen. Now we have to look very carefully to make sure that these columns do not clash. Okay, do not puncture and become exposed on the first floor level. Now on the ground floor level, they are starting from the foundation level. So because we look at the architectural design, okay, we have the columns from the ground floor, okay, all freestanding, they are unbraced. You have no problem from the ground floor to the first floor. But then the issue is that you must make sure your columns do not clash with the vehicles. So the vehicles have been positioned. In your development of structural layout, must be certain you have sufficient clearance of your vehicles and that your vehicles and columns do not clash. You don't have any clash. Okay, this is a closed one, but that vehicle can also move backwards, so there's no problem. Okay, you ensure that your columns do not create a potential interface issue with your vehicles. That vehicle can move backwards, there's space there, so we have no problem. Okay, if you can come in here and go in there, that can also park in there. So you look at these ergonomics in your structural design when positioning your columns, especially in high-rise structures or mid-rise structures such as these that are elevated above the ground level. The next thing we need to look at is, so we said earlier on that you use the ground floor and the first floor architectural layout to develop your first floor structural layout. You use the first floor and second floor architectural layout to develop your second floor structural layout. In the same vein, you use the third floor and fourth floor, second floor and third floor architectural layout to develop your third floor structural layouts. So we want to look at how we had developed this using the ground floor and first floor. This is the ground floor architectural layout. Now let's switch on the first floor architectural layout. Okay. So if we look carefully, okay, so on the first floor, so we've taken off the ground floor. On the first floor architectural layout, what do we see? Let's try to okay, good. So I'm trying to take off unnecessary information. Good. So if you look at this, let's look at now. Look at the way we have positioned the beams. So you try as much as possible to optimize your beam spans. As much as possible, you would want your beam span to, vary between 4.5 and 5.5 meters. Where rarely it's impracticable, you could go up to 6 meters. But in your design, you must ensure that deflection is satisfactory and does not impede on the aesthetics and cause damage, okay, at serviceability limit states to claddings or different type of architectural finish on your beams. So if you look at, we had framed this beam, okay. Now we had positioned the columns. You position your columns carefully so that your columns flush with the walls. Let's remove the beam so that we can see where these columns are well positioned. Okay, so you see where we had positioned these columns, right? The columns are well positioned such that they flush with the wall. Now, but there are two columns that we were not able to achieve our structural objective. Now this is this column and that column. Now why was this so? Let's look at this carefully. Now this beam is designed to be continuous up to that point, and that beam is designed to be continuous up to this point. At this location here we have a window, and at this location there is a window. Now these columns are carrying the beams on the superseding floors, and they are essential and they need to be where they are. They need to be positioned where they are. So we wrote back to the architects that these windows would have to be repositioned. These things happen once in a while when carrying out structural framing arrangements, and that's why they need to be close-knit interface between the structural engineer and the architectural and the architects. So if you look at the architectural design, you would see that where that beam or where that column is going to be, okay, where the column is starting from on the first floor, you have, so let's look at that's the first to third floor plan. Where that column is starting from on the first floor, you're going to have a window. There's a window there, and that column is going to puncture through the window. So this window would have to be relocated, either moved, rightward or northwards, or repositioned entirely without adjusting or impacting negatively on the original architectural aesthetics. Okay, so this is the first floor structural layout. So the building has symmetry, line of symmetry. So what you see on that side is the same as what the architect has done on this other side. So the same structural framing you have developed on this side is a mirror image of what you have on the other side. So like we said earlier on, the white columns are columns that terminate at the surface of the first floor. Reason being, if you allow that column to go up, it's going to puncture into this slab panel. Okay, so this is a slab panel. That's a slab panel. Okay, and that's a cantilever. This is a cantilever on this side. So if you take away the architectural design, you'll see the structural framing. You will see that that's a cantilever, because like we said, you see that the ground floor terminates at that grid. Okay, the first floor projects outwards. If you look at the first floor, you see that the first floor projects outwards. So that's a cantilever, and this is the line where this beam terminates. So this beam projects here, and this column starts from this beam, okay, to carry the next floor. So if you allow this column to come up, this column is going to puncture into this slab. So the slab on the first floor, if you walk into this room, you'll be seeing this column, and it's going to impede on their aesthetics. So these are the decisions a structural engineer will have to contend with when carrying out. So you contend with safety, structural integrity, and aesthetic. Your structure must be able to be built with economy. It must be designed to be economical. It must be safe, and it must not impact, it must be fit for purpose, and must not impact on the the safety of the personnel who would occupy the structure. Okay, so we also have this cantilever on the first floor. It's a cantilever because, like we said earlier on, the grid from the ground floor terminates here, and then the first